Now reporting and remind you what we are going to do. Now, as we are not able to see video immediately from class, we will work with this Telegram explanation. And what does it mean for you? That you have already in your group, beginning of laboratory class, and you suppose it to understand where the end of laboratory class. You have this report both in Mentor and in Telegram file. You have printed it. Who have not done it yet, please do it. If even you haven't printed it, it's easy actually to draw, because this time you have no difficult task. What is your task? You see the same picture twice, picture of Spar. This picture is not finished above the all. It means that even to reproduce it finally as a Spar, to represent it as Spar that you're going to work with, you need to add some elements to drawing first. And next in this drawing, you need to show, it's called locating chart. Locating chart, it's a diagram which shows basis, processing basis, technological basis for all parts. Basis which take out degrees of freedom of part in order each part disambiguously located during assembly. So it's picture which in symbolic way shows basis of each part. Why you have two pictures? Because you're going to study two different assembly methods. What is assembly method? Above the all, it comes about locating for you, how to find position of each part during assembling. In the most wide understanding and according to correct definition, assembly method is the set of rules how to reach demanded accuracy of dimensional chain, not even dimensional chain, but closing link, final link of dimensional chain during assembling. That is assembly method. So you need to find position of each part during assembling in order to reach demanded accuracy of the spar as a whole. You may do it by some different ways. In laboratory work, in particular, you study two of these ways. One of them, it's easy peasy, let's say, without any special tooling, maybe fulfill it immediately on labs, how people call it, and on the labs. Usually it's fulfilled in special workbench. This workbench is almost the same as a table, but it consists of vertical plates. In order you may have access from bottom and from top to elements of structure. Usually this workbench looks like a set of plates vertical. In our class we have no such workbench, we have only standard workbench. You may see it in a photo. And guys, I forgot, I supposed to show you screen. I'm talking, and think why you not see the same picture as me. I have noticed it in a phone that I forgot to show screen. Maybe now it shares the screen. Is it? Yes, at last. Sorry, because of significant stress. Now I have problem with with memory. You know, two pictures. You see, one picture of SPA, second picture of SPA. One time you do it for assembly holes method that I said immediately on labs. And first technological process here, the sequence of operations, you see, sequence of steps to be frank, correct. Sequence of technological steps altogether will be technological process. First technological process you are writing down in this table, assembling by assembly holes. Second one, you have another table here, technological process in a jig, and in this case seems like assembly procedure more complicated because it will require special tooling, and to be frank, this method of assembling will be more expensive, seems like. It's not quite the same, it's not quite correct, because in order to say what is cheaper, what is more expensive, assembly holes or assembling in a jig, we first need to calculate it. And next, in future, if we have such opportunity when we study it, I will show you that this statement that assembly holes are cheaper, it's not correct, because it depends on how many items you're going to assemble in a jig or by assembly holes. Above the all, assembly hole, first method, that one, which you're going to reflect here, it's not so accurate with respect to assembly jig. In assembly jig, you do something more accurate. Assembly holes do not demand special tooling. It means that you may have technological preparation not so long, like in case of using of assembly jig. But anyway, you need some assembly preparation, pre-production, let's say, lead time, because it comes about coordination of holes above the all in manufacturing of parts. But it would be mostly in parts manufacturing preparation. And when it comes about preparation to assembling in a jig, it's quite clear. First, you need to design the jig. Next, you need to produce the jig. And as I'm already explained you, reminded you, explained it third year and explained it last time, that before we start manufacturing of jigs, first we need to design and to produce some tooling which is necessary to produce jigs themselves, to assemble jigs. That is also the problem. So both of these method has advantages, disadvantages, has strong features, has weak features. And at the end of lab, you are supposed to make conclusion. Do you see this table? Forget about this table. We can't give you now this experiment to do. So we do not fulfill it. We just explain you that clumping, amount of clumps, clumping, which is also the stage of assembling. You know that assembling is locating, next temporary clumping in pre-located position, and next creating the permanent joint. When it comes about the clumping, the more clumps, the better. No, like in the most general explanation. And in this experiment, we are usually study that clumps affect on the accuracy of assembling. We are not study the tendency, is it better or worse? Because in order to study exactly the tendency to get accurate data, you need to fulfill some thousands maybe of such experiments in order to insist something. But here, at least in such experiment, we have seen that clumping with that or another amount of clumps, with that or another position of clumps, resulted in different accuracy of assembling in the same jig. Jig is the same, but depending how many times you clump it parts in the jig, you have that or another result of accuracy. So what you do once again, you do locating chart for assembly holes, locating, and you write technological process. You do locating chart of assembling in assembly jig, and you are writing technological process. Pay your attention. On the left, you have steps. On the right, you have tooling. Steps must be numerated. 1, 2, 3, so on. Tooling, you are not writing in a heap at the beginning or at the end. Tooling corresponding, each line of tooling correspond to each line of technological steps here. For instance, prepare working place, open clumps of jig. Here you're writing once, assembly jig. And next, as only you have written this assembly jig, you don't need to repeat it. Until you state in assembly jig, you don't need to repeat it. But if something new appeared, for instance, you take in hands screwdriver, or some wrench, or you need some additional clamps which do not belong to the jig. In this case, in front of what you do, you need to write down what you need as a tooling. When you're writing, for instance, drill 42 holes. If you're drilling 42 holes, you need drill gun and you need drill bit. I hope it's clear. Next, once again, we do locating chart, process, locating chart, process, and conclusion. You suppose it to submit it immediately today after class. That is why I asked you to watch and to read what we gave you as description of this laboratory class. I'm not going to explain everything perfectly right now, just to remind you some basic points. And once again remind you that for first time, your task is even easier, because as only I finish this video explanation, I'm going to help you with technological process. You will see it in your group immediately. Now, let's continue. No, that is place which you're supposed to read explanation what we understand as technological process and some elementary explanation how to write the technological process. Pay attention here. Text of technological process of large-scale production and so on. Those you're supposed to read. It's out of your laboratory manual. Laboratory manual is laboratory manual is here, you see. And laboratory manual, you know, what I did. Laboratory manual is in your group also. Так, куда мы потерялись? Вот мы. Oh, here, the link for it, and you have it. I hope you do remember. Next is description immediately of this laboratory work. And what we are going with SPA. Now you see cross-section of SPA. And this cross-section illustrates you what does it mean to assemble something by assembly holes. It means that we align parts using, actually even locating chart here have shown on top line you see for assembly holes, but they are not finished, of course. And at the bottom line, you see something for locating in a jig. You see difference in parts before assembling. To pay attention, they are different. In explanation, you have read it because amount and purposes of holes, at least, they are different. In some cases, you have assembly holes and guiding holes, pilot holes in caps. In another case, you have only guiding holes in caps. You have no assembly holes. In one case, you have assembly holes in web. In other case, you have assembly holes in less amount. And base holes or coordinate fixing holes, you may have call it like this, like that. In this particular case, doesn't matter, but use the same name each time, either CFH or base hole. Up to you, but the same name permanently. And what you see in the first illustration, it's how to locate something by assembly hole. You see that we temporarily use holes for permanent joints. In this particular case, what will be the holes for rivets? Some portion of them we are going to use for locating. How exactly? No, that is assembly drawing of SPA that you supposed to describe, you supposed to assemble. And here you see a photo of pre-assembled such a SPA of laboratory class. And you see results both by assembly holes. Immediately, as I said, you may be assembled on a table, on a special workbench, or just on the floor, to be frank. And another one in assembly jig. Assembly jig in our case is so-called readjustable. It means you may assemble there some spars. Next, after you finish the batch of spars, you readjust it. Procedure of readjusting it's described at the end of laboratory class, and readjust it for another unit. Next, you assemble batch of another spars or another ribs using the same locators, using the same clamps, and formally it will be another jig already for another item. It's just idea of readjustable jig which helps to save money. What is the problem of readjustable jig? It's not so convenient for employee as special jig. No, that is the matter of our second half of semester to study. Now just take this idea in your mind that readjustable jig is cheaper, but it's not so convenient. Also, it may suffer with accuracy. So let's start assembling by assembly holes. You heard what did I say? That we may align some holes, literally what aligning these holes in parts. And you see that they correspond to holes for riveting, but only some of them we are going to use as so-called assembly holes. How many exactly? In a book and in my explanation, I trust you have read the distance between assembly holes should be not greater than 90-70 centimeters. Well, literally not more than meter. It means that each meter you have additional assembly hole. If you have here the length 2 meters, you see 3 assembly holes. If you have 5 meters, certainly you have not less than 6 assembly holes. It's for stiffness of parts. Before assembling, parts looks like this. You see assembly holes in a web, and you see assembly holes in a cap here. And you see additional couples of assembly holes, one couple, another couple, third couple, and so on, 5 couples for these stiffeners. And stiffeners in their turn have assembly holes. Pay attention that these holes, they are not aligned in one line. In order, it's called foolproofness. In order, your employee can't switch off, can't mix up holes for one stiffener for another. For instance, this stiffener, it may be attached only to this place. You can't attach it, you can't align it with these two holes because holes does not coincide. And the same, do pay attention, made with these holes in cap and in web. Do assess this distance and you'll see that this distance and that distance and is different. And even these two distances may be different. In order, no one may rotate it in another position, this cap. In order, no one may mix up top cap, bottom cap. Holes do not give such opportunity to employee. Employee in serial production shouldn't think. You are, during pre-production, you are engineers thinking, employee working by hands. You are paid for your brains, they are paid for their skills, manual skills. Here is a photo that demonstrate you aligning of, no, do forgive me when I click it quickly, you see overlapping with text. You see aligning of assembly holes should be, and other holes that you see in a cap, they are so-called pilot holes or guiding holes. In our literature, you meet it as guiding holes. What these guiding holes are necessary for? Pay attention, in a web, no any hole for riveting yet. What for? Because we are going to drill them together next. And we're going to use these guiding holes, pilot holes, as conductor for drilling during assembly process. It's quite typical decision. It's used everywhere, including the leading companies like Airbus, Boeing, Bombardier, and so on. It's not because of primitive technology, because it's cheaper. It's easy, cheaper, and everyone do it. Now you may even see that this operation, drilling of holes in assembly, drilling of holes together, it just pass it to, no, let's say to hands of robots, no? And this robotic drilling, cleaning of holes and next riveting, it's quite common now in leading enterprises. But anyway, they use the same trick. No one try to drill holes beforehand in manufacturing of parts. Everyone do it immediately in assembly. These parts now are aligned, kept aligned with respect to the web. Now, those of you who are the most attentive, they may ask why we have here additional holes in the middle, like base holes. Just because we have no two sets for our laboratory class, we use, if we come back here once again, you see that another cap, it has no assembly holes. During the laboratory class, we are pretending that one side is for assembling for one method, and another side, another cap is for assembling in a jig. So just happened like this. And once again, after you have aligned everything, but it's not fixed yet, it's not clamped. As only you touch it, it's already misaligned, and you must clamp it. How you may clamp it? In our laboratory class, we have so-called technological screws and nuts. They are very convenient for installing, but they are a little bit longer in installing. They are simple. They do not demand any special tooling. Even even wrench or screwdriver you don't need. You may do it by fingers, but you need access from both of sides to this. And you understand that to rotate some wings of thread, it takes you time. And you need at least 2 such clamps in each meter. So it's rather long procedure for employee. And on the other hand, we have special special devices which are called clicks. I'm going to, no, that is drilling together, that is robotic assembling, what are we talking about. Pay attention beforehand, before I even try to explain it. While drilling, we compulsory have some portion of trash. They are called flashes, which stack up immediately on the hole, and dust and chips. All this, when you drill some parts together, it may appear even between parts, in a stack of parts. Just take it in mind yet. And no, in this video, I'm not going to show it now. In this video, you have seen, I trust, their clicks, what I'm talking about. Clicko, they also have name in English. Let's search them. Where is this Clicko? Oh, no, maybe it's later when explanation comes immediately. Yes, there are. Look at them. They are. Да? Clearcore, or we call it clips. They may be inserted, installed immediately from one side, like with one click. But problem is that you need special tooling. You need these special clicks, and you need special tooling for this. Так, уважаемые, let's come back to the previous. Так. And it was only about locating, how to find positioning, how to find position, how to positionate, or how to make positioning of parts assembly components during assembling. You see that one cap will locate by assembly hole, another cap will locate by assembly hole, and here we have also stiffeners located by assembly holes 5 times. Next, young talents, next. Next, we are going to talk about how to assemble something in a jig. Jig, you see. Results supposed to be the same, web assembled with one cap, another cap, and 5 stiffeners. But now we use special tooling for this. No, it's not special. Once again, it's readjusted tooling. And pay attention, photo is the same once again. Yeah? Now we are going to use these inner holes, so-called base holes or CFH holes, which are suited, placed immediately on the axis of Spar. Where the drawing, the closest drawing, maybe next step. No. Okay. And what else we're going to use? Caps we are going to align by jig locators, special stoppers, special device which show stop here, do not move far. No, of course, that is why we're going to show you the video, in order you may imagine it better, in order you may see it. Next, it comes about assembly holes. Look at this. Locators for cap, no, maybe you not understand what they looks like right now, immediately in the photo, but locators of caps you see 3 locators on one side, 3 locators on another side, but no any locators for stiffeners. How stiffeners may be located? And you see that in order to save money, and because demands to accuracy of these stiffeners it's not high, stiffeners also located by assembly holes. Question is, why we say that we locate in a jig, or we assemble by jig, or in a jig, if we use at least 2 different methods of locating in a jig? On one hand, caps are located by contour. On other hands, web located by CFH holes, by holes, it's another way of locating, another method. And moreover, it's appeared that assembly holes are also in use. Why we call it locating in jig by contour? Because when you assemble something, really you use a bunch of methods, the whole heap of methods. But it's one of them determines the final accuracy. What accuracy we are interested in? We are interested in this vertical size, to outer surface of top cap and outer surface of bottom cap. This accuracy we are interested in. This accuracy is determined by contour locators of jig. That is why we say it's assembling in jig by contour. But really, we use 3 different assembly methods here. Once again, what is the method of locating? Answer me, please. Who do method of assembling? I have already answered instead of you. Say me, what is the method of assembling? Method of assembling is method of locating, method of clamping, or method of joining. What is it? Or it's all together? I ask you the question. People, don't play dead. Answer, please.
Please, can you repeat the question?
I said, answer me, please. What we understand as assembly method? Assembly method, it comes about method of locating, or assembly method, it's method of clamping, or assembly method is method of joining.
Assembly method is method of joining.
No, dear. John, thank you
Locating,
that you
sorry.
have answered. You was the only at least who have answered. All other play cheats, do forgive me. Look at this. Yeah? Assembling is, do you remember this fantastic creature? Three-head dragon. Assembling is locating, clamping, and joining. What is assembly? Altogether, it's called assembly process, assembling. The whole dragon is assembling, but really it consists of 3 different, you see, quite different steps, and they are all different in their nature. Do pay attention. One looks dreadful. This locating, fire breathing, so awful, but he may only scare someone by the steam. That one, clamping, why it's crying? Because students never remember that they must clamp parts. They do not mention normally clamping of parts in their technological process. That is why it's crying, because no one like him, no one remember him. Joining, do pay attention, such a gentleman. It has tie and neck, very beautiful hairstyle, you see. But also it has dreadful teeth. Visible?
Yes.
Joining is the worst ever thing in assembling, because joining creates a lot of problems in real life, and it's joining which takes around 75 of labor input of assembling. If you remember, I said that manufacturing of airplane is around like 3/4 time. No, let it be 75%. It's little overestimated. No, let it be 75% of manufacturing of airplane we deal with assembling, and out of assembling 75% of labor input, 3/4 of labor input, we are dealing with joining. All this drilling, cleaning, riveting, and so on. And kind of assembling is joining. Kind of assembling, riveting, kind of assembling, adhesive assembling. Method of assembling is always about, no, actually these two, about locating and clamping. Suppose it to be about locating and clamping, because clamping also affect on the accuracy of assembling. Method of assembling is the same as method of locating. When it comes about method of assembling, it's how to positionate parts, how to locate them, not how to join them further, but how to locate them only. And what we're studying right now, how to locate part of this spar in order to reach demanded accuracy. One way, align holes, another way, in a jig, in such a jig. Also, in that explanation, I tried to explain you how jig is appeared, what jig looks like without parts. Look at this. You see, it's like a set of supporting platform for caps. You see this. These stairs, they are necessary to support caps. These necks, these little giraffes, they are, by the word, do you know another designation for giraffe? Camel apart. Have you heard such word? No?
No,
Never. Camel apart. May you imagine? Remind me, I will show you next after the class. And these little creatures with long necks, these dinosaurs or giraffes, as you'd like, They are clamps. They are necessary, they put down next, and they are necessary to clamp part immediately to that side of stair and this side of stair. Where the clamp for web. Here is this clamp for web. It looks like platform with pin. You see. I hope you see. Oi, too much. That one. Platform with pin, and this platform, it's placed in particular place here. How it's appeared that they align it, it's another story. At the end of lab. They are aligned onto one axis, and all these locators, they are placed at the proper places with respect to this basic axis. And altogether, this set of locators provide accuracy of locating of spar parts. Next, you just put the web onto these two holes, attach cap to these locators. You don't need even think. You don't need even to see any holes. You just attach, 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 and close clamps, and no problem. And due to this, you have demanded accuracy. No need to measure something. No need to count something, to calculate something. Just attach, attach, attach. Put on, put down, attach to. Not really in real life. That's what I was talking about. Employee shouldn't think. Employee working by hands, you are working by brains. Before employees start work with hands, by hands. Let's come back to Jig. How to align something in a Jig, you see. Put the web onto these two pins. Next cap, you see the cap. Next cap would be moved to these locators. Here is, you see. Locator clamp, now it's closed. And all together, you see locating of cap with three locators, by three locators. And now all of them are closed in lock, for locking it, for clamping it in this position. Next, the same things we do for this side. And that is another story. In order you may see what these locators looks like. I even highlighted here with red color cross section of spar cap that we're going to locate. You see, no? No, that one is more complicated. It's so called a standard one because we have standardized equipment and elements of tooling. We have standardized. That is a standard one, which is even a bit more adjustable. If necessary, you may even rotate it with different angles. So on. It's more complex. That's something we have in class. But generally, it's very similar. Pay attention to this photo. Visible, not visible. Oh, visible, yes. A little bit more blacky than necessary, but visible. And to such a clamp. Here is simplified clamp. Simplified picture, not clamp, but picture simplified. And here is it's two function, locator and clamp. Here is the whole view and complicated picture. And that is in a closed position, you see. No, and about assembly holes, I already said that stiffness would be located by assembly holes because we have no high demands to accuracy. Pay attention that now all parts together shows where to drill holes. Pilot holes show drill here, but pilot holes it's less in diameter than assembly holes. In order not to mix up them first. Secondly, this CFH hole or base hole, it's much greater in diameter than any holes for riveting. Usually they are diameter 5 or diameter 8. We studied this even at third year. And pilot hole usually is with diameter 2.6, like minimal possible diameter for minimal possible rivet. But next they are increased in size. They work as conductor. They are template for drilling. This part now working as template. It just show where to insert the drill bit. That's it. And next you are drilling one by one, increasing this hole. But I hope you remember that after you did it, you have awful results. Where it have been these awful results? creeps, chips, flashes. So after we drill holes, first we have so-called preliminary dismantling. We dismantle parts, again, remove them from jig or remove it next, assembly holes and assembling in a jig. Process is very similar. In that example of process that we're going to give you, you will see it's almost the same. Remove parts from jig or remove parts, unjoin parts at least from each other, clean parts from flashes, by metal brush, by filer, whatever. If you read explanation, I hope you read all those things already. Sorry that I'm blinking here. About Klekas, да, you also. That is the book Reaffordable, so on, да? Reaffordable Assembly Jigs that I said you to read. And there in page 24 or 22, 24 maybe, if I'm not mistaken, it's explaining the whole procedure of this unit assembling, step by step also. Now what it looks like, you have seen, including the keys that you need to work with. And next, when you have clamped everything, next drill it everything, next dismantle everything, and next you assemble it again, whether by holes or in a jig, now it doesn't matter. Pay attention by the word that after you drill all the holes, there are no assembly holes. All holes now are equal. All holes are correct. All holes are equal in diameter. And no, I mean for inside of one part, inside of one couple of parts. And all of them may be used as assembly holes now. And. Next, we're going to rivet. What rivet looks like, just to remind you, so-called manufactured head, this rivet head, it was done preliminary. Rivet is pin or shaft, it's called, да? Shaft with manufactured head. Shank even, not even a shaft, but shank. And such a pin with preliminary manufactured head is installed. We have seen it also somewhere here. It's installed in the hole like this, and next it should be hit from another side or from that side or from another side in order to create locking head, or it's called shop head, which appeared immediately in a shop. No, that is explanation. I took a picture with explanation of mistakes of riveting, with problem of riveting. It's not interesting for us right now. For us, it's interesting that we need to rivet it somehow. We, after installing it in the hole, we need to upset somehow this shaft in order to create locking head. How? At least we have two ways. One is using stationary equipment, press. Another one, using manual riveting gun. What is the difference? Finally, difference in quality, by the way. First is the difference, here you just place the item to rivet, click the button, equipment do one motion, and you have riveted joint. What about rivet gun? No, if your highnesses have seen movie, you know that riveting gun working much faster than I have shown now, and it's working during couple of seconds to make one rivet, one joint. But during this couple of seconds, you do around 2 dozen, 3 dozen of kicks, impacts. Sorry, I'm already got tired to talk about water. And above all, no one able to count how many times you already made impacts. Even very qualified employee can say it was 25 kicks, let's say, strokes, or it was 22 strokes. Secondly, it's not stable. method. You can't provide the same quality of each rivet if even you have high qualified employee. Thirdly, it's only high qualified employee who may work with such rivet gun. And here you may find any girl, do forgive me, from street. Just explaining, here's a button, and that is the place where you shouldn't insert your fingers to. And this girl will work with very high quality. And moreover, in this case, do forgive me, in this case, you can't use one employee, because when you are riveting something like this, compulsory one is riveting, another one is supporting from other side this rivet. While press may do it immediately on its own. Here you see so-called S-like, C-like in your language press, which work like, no, they are also may be called squeezers or squeezing press for riveting, which work immediately on a table if necessary. And also we have manual squeezers or little portable presses of the same type, which you may use immediately in a jig somewhere or immediately on a table. When it comes about big stationary press, it means that you need to transport your item to this place because you need to remove spar from jig, for instance, and transport it to another place of shop to work in press. When it comes about squeezers of manual type, you may come with this squeezer. You may come with the squeezer immediately to the jig you are working in. No, that is explanation of process. What it looks like in schematic way was nomenclature of items. Pay your attention that is so-called buckling bar. This buckling bar in the hand of another employee, of second employee. And here you have more explanation about these buckling bars. So I have collected more information for you, so on. Pay attention also to this photo. It's already, of course, sophisticated manufacturing. And what you see here, it's huge riveting press, but really huge. And in big assembly enterprises, they have the whole shop stuffed with such presses, and they are computerized, as you might see. What you see here, that panel here is, a little panel. No, it's not little, of course, it's big panel because it's a passenger door, some windows, you see it. Panel placed immediately in some supporting device, and table of press, it's not just movable, it's even rotatable in order to align axis of each rivet perpendicularly to the working device, to the spindle of this press. Here on the back side, you see some jigs which are placed, they are moved here in the shop. They are just waiting for their turn, do forgive me, in order to be replaced to this press for riveting. That is, of course, great way, but it's not convenient in terms that you need to move either jig or to some supporting device. You need to move it onto table press. Create a lot of difficulties. More convenient way is robotic riveting. Pay attention. You don't need to move item to special press, but press moves to your item. No, of course, compulsory it must be couple of robots. One robot from one side will be, and another robot from another side. All like this, if you have open access, if you have access from both of sides. In this case, robot hands is finished with such a squeezer that I already were talking about. No, in your laboratory class, you don't need to write down such complications, but just to give you the most general idea. What did I say before? That we have the whole shop stuffed with, pay attention, it's one press, next is another press, and so on, stuffed with such presses. And now maybe it's a little bit more understandable why at all we do this so-called breakdown of structure, why we assemble structure by pieces. What if we start assembling immediately in a little bit in one jig? If we do everything like in one working place, pay attention. In this case, if we place all the parts here immediately and start drilling them, riveting them, and so on, we are tightening it in place. That is a huge airplane, by the way. Considering it's comparatively to the employee size, it's so-called wide fuselage, 6 meters, 7 meter diameter. It's exclusion in the vault of our airplanes. Huge airliners, they may be 10% of all the airplanes, yes? Usually airplanes are much less in sizes. And in order to invoke them, employee even, no, I don't know, squeeze it inside, employee in such positions. Maybe I have seen, I have shown you such photos already in our summer practical training, how they squeeze it inside the structure in order to get access to riveting places. And of course, in this case, it will be much slowly, everything. But if we break down structure onto pieces like assembly units, panels, sections, we may do work on parallel. On one hand, it's reduced time of assembling altogether. Labor input may be the same, but time of assembling is less because we're working parallelly. And on other hand, in this case, we create pieces with open access for joining places. And that is important because in this case, we may use less human manual work, more automated work, like we use equipment, even elementary things like press, squeezer, and so on. And we may use even robotic equipment. That is better, but that is idea of this dismantling. But of course, it has point only if you have large scale production. If you're going to produce one airplane ever of this type, you don't need such complicated manufacturing. You will do everything like, no, really, on the bench, on the lab. Here is the video about robotic assembling. Watch on your own, please. Так, ну, the same video, I'm just remembering that from YouTube things time to time disappearing or they start so-called not free access. Да? What do you see here? Robot make drilling. Of course, here they are much talking because it's advertising video. Thanks to them. Nevertheless, pay attention. Now it's riveting. Two robots, one is inside, another is outside. Due to the advertising video, we have access to watch something. Так. No, that is couple of robots on one platform, but they also have companion robots from another side, and they are explaining this, that they have companion robots. No, please watch video. Very simple and very interesting. Так, let's come back to our lamps, people. What we need to do? Two technological process. Do forgive me, you will copy down this technological process. No more, no less. Yeah? Two locating charts. Do forgive me, these two locating charts, they are also represented here in channel, and I will show you where they are. Pay attention to such effect also, that we give you additional task. Where this additional task is, do forgive me. You have seen it, but I'm not explaining it. I mention it, but not explain it. But also, you may just copy this additional task. Just be accurate with the amount of holes. It's so-called part supply conditions. It's one of tasks that you next have in your assembly portion of your bachelor work, bachelor thesis. For your item, of course, for your rivets, for your panels, for your spars. Here is, you see part supply condition on one hand when we do something by assembly hole, and on the other hand when we do something in a jig. As I already mentioned, depending on which method we are going to use, parts are non-finished in that or another way. What in particular? Caps, pay attention. If we assemble something by holes, caps finished by contour and have 3 assembly holes of diameter 3.1, 34 guiding holes of diameter 2.6 millimeters. What about if we're going to work in a jig? Cap finished by contour, and instead of these 3 assembly holes and 34 guiding holes, it has 37 guiding holes of diameter 2.6. Already a difference. The same as with web. Web finished by contour, 6 assembly holes diameter for caps and 10 assembly holes diameter for stiffeners. And if we work in a web, in a jig, a web has 2 coordinate fixing holes for locating to jig, and it has 10 assembly holes for locating of stiffeners, but it has no these 6 assembly holes, and so on. That is something like instruction. That is for those who manufacture the part. And I hope you do remember that during pre-production, we are not start with pre-production of part manufacturing. When in manufacturing, first we produce part, next we assemble units, next we do final assembly and testing. When it comes about pre-production, we goes in backward direction. First, we develop, decide everything about final assembling. We develop technological processes of final assembling. Next, we develop technological processes of aggregate assembling, and only after this we comes into technological processes of parts manufacturing. Because parts before assembling does not look how you see it in a drawing. They are maybe non-finished in that or another way, depending on which assembly method you're going to use. It was one additional task for you. No, again, it comes about copy down, do forgive me, but just be accurate with amount of holes. Maybe in this drawing you have another amount of holes. And one more task, it was to describe procedure of jig mounting. And where it started, let's see. Oh, here is da. No, it's not yet. It's yet a description about technological process. Where they started, here is one more additional task for you. We demand you to write down technological process of jig mounting. This readjustable jig, which may be mounted for that or another item, it's mounted by template. How it's mounted, we will see it in a minute. No, not see, but in the photos only. And where you may write it in your reports, you have no place, seems like. Yes, yes, but you have backward side of your printed form. On back side of this printed form, please don't be lazy. Write down this. If you'd like to have full score for your laboratory work, for this laboratory work, you have here one more task. Don't say that you haven't heard of it. And here is once again, it's reminding for you. It's coming back to laboratory class of third year. Yeah? It's reminding about methods of coordination. On one hand, we may assemble something using mock-ups or templates. On other hand, we may assemble something using measuring by rulers or some another way. Here is either you're using natural mockups in order to attach all elements of jig to these natural mockups. No, like template or standard mounting standard or some mockup or some gauge, or where comes into measurings of position of locators or holes in locators and so on. Just to remind you what it comes about. Such diagrams we have studied at third year. And next you see procedure of jig mounting. Above the wall we have workbench. Workbench have special T-slots, you see it. Inside of such T-slot we insert bolt upside down. Head of bolt here and shank of bolt is here. All the locators, all the locators that you see, here is little one. You see, locator itself, after we positioned it, after we found where it's supposed to be, it's clamped with a bolt, which squeezed in such a slot. Bolt, and here is the head of nut, washer, nut, and it's clamped firmly, permanently in some place. No, not permanently, but until you need it. Before assembling, before mounting of jig, we have workbench. Next, we have template. Template is rather similar to the Spar, but it's flat, and you see at the side it's reinforced. It has special bars here in order to increase thickness of template. And template has the same system of holes that you need to repeat in a jig. Literally, it has only the base hole or CFH hole. We don't need here assembly holes, we don't need anything else. We need only, as we need locators of CFH, we need only locators, this CFH in a template. And this CFH we are going to repeat in our jig. And preliminary, we have some standard devices, standardized devices that we may buy, for instance, by internet. Yeah? Well, what is next? First, we approximately place couple of locators. What approximately? We align them in one line, but line, it means that line between this pin and between this pin. They may be rotated, oriented, however, after you place it, and distance between them also, whatever. Next, either we go to measuring or we use more simple thing. Pay attention. Place here the template and align these pins by holes of template. And next, when they are already, here is that visible, you like put on template onto these locators. Of course, you need to move them a bit to adjust them to the template. And next, you will clamp them on the table, as I said you, with the nut. Fix it permanently. What is next step? Next step, the same approach. You are attaching the locator immediately to the template contour. And locator here at the bottom has similar, anyway, not visible, sorry, to black photo. It has similar story with clamping. It has bolt, and you adjusting this bolt to fix locator. And next we repeat it for each locator. Attach locator to the contour of template, fix locator to the workbench table. And finally you have the whole jig. You see a little bit more tooling here, those posts or stands with additional pins. They are for experiment with measuring of accuracy. Don't pay attention to them. Really, your jig consists of 2 pins for base hole or for CFH and 6 locators which are necessary for locating the caps. After we remove template from jig, and we have final jig, that one are ready to receive parts of serial manufacturing. And here is, you have once again explanation of this technological process that you need to describe in your laboratory class. Technological process of mounting the jig. So once again, let's come back. Так, where shortcut to beginning of lab. What you need to do? You need to make locating chart for Spar and to write technological process of assembling the Spar by assembly holes. You need to draw locating chart of Spar locating in a jig and its technological process in a jig. You need to make conclusion here. On back sides of your papers or on separate page, you need to describe procedure of mounting this readjustable jig. And also you have one more task which you're going to copy down. It's description of part supply conditions. What part looks like before assembling. For that to another method. Guys, I'm stopping the record now.